Have you ever noticed that, after running current through a coil, the electromagnet can actually change its size, just a little bit? It's not something you can see with the naked eye, but with the right instruments, you'd find that the metal core inside the electromagnet expands or contracts ever so slightly. These are tiny, almost invisible changes, measured in millionths of a meter, but they're absolutely real. This effect is known as magnetostriction. Magnetostriction is one of those hidden forces at work in the world of electromagnetism, quietly shaping how our devices behave. Picture this. You've built an electromagnet using an iron core, carefully wrapped with copper wire, ready for action. The setup looks simple, but there's a lot happening beneath the surface. When you flip the switch and send current through the wire, bam! The iron core instantly becomes magnetized, turning into a powerful magnet. But there's more going on than just magnetism. As the magnetic field surges through the core, the iron atoms inside start to align themselves, almost like tiny soldiers standing to attention in perfect rows. This atomic realignment is what causes the physical shift in the metal. When the atoms line up, they nudge each other just enough to make the entire magnet expand or contract, depending on the direction of the field. It's a microscopic movement, but in the world of precision engineering, even the smallest shift can have big consequences. The change is so slight, just a few millionths of a meter, that you'd never notice it by eye. But in certain machines, especially large transformers, you can actually hear a faint buzzing or humming sound. So what's behind this noise? Let's break it down. The number one culprit is usually loose laminations inside the core. These laminations are crucial to how the core works. Laminations are thin sheets of metal, stacked together to form the core of the electromagnet or transformer. They help reduce energy loss, but only if they're tightly packed. If they're not, problems start to appear. When magnetostriction occurs, these loose laminations can vibrate, rub against each other, and create that telltale buzzing noise you sometimes hear in electrical equipment. The vibrations can even lead to wear and tear over time. So, if you're ever asked whether magnetostriction is caused by loose laminations or loose windings, always pick laminations first. That's the most common source of the issue. It's a classic question in physics exams and interviews. Most of the action, the movement, the noise, the energy loss, happens right there in the core, between those metal sheets. But what about the windings? The windings or coils of wire can also cause trouble if they're not snug against the core. Loose windings can vibrate when the core shifts, adding to the noise and sometimes even causing electrical faults. But compared to laminations, windings are a secondary concern when it comes to magnetostriction. The main event is always in the core. If the windings aren't tight, the shifting core and the changing magnetic field can make them move, leading to even more vibration and noise. That's why both parts need to be checked, but laminations should always be your first stop. So how do you fix magnetostriction and the annoying hum it causes? The answer is simple. Tighten up those laminations. Make sure every sheet is pressed firmly together, leaving no gaps for movement. Use clamps, bolts, or whatever tools you have to secure the core as tightly as possible. This will dramatically reduce vibration and noise. The tighter the laminations, the less room there is for movement, and the quieter your electromagnet will be. If you ever hear a mysterious buzz coming from your transformer or electromagnet, check the core first, then inspect the windings. That's the best way to diagnose and fix the problem. It's all about making sure every component is packed solid, with no room for anything to wiggle or vibrate. So next time you hear your lab's transformer humming, or you're faced with a magnetostriction question, remember, it's those tiny atomic shifts inside the core, usually because of loose laminations.